What makes a good goal? That's the question that we're going to discuss in this segment. And as we talked about in the introductory video, we know that goals are first of all to clearly identify the learning outcomes of our lesson. They're also used to guide instruction and for progress monitoring. But in this segment, we're going to focus on the first point, writing goals that clearly identify the learning outcomes. The book Principles to Actions, which first introduced the 8 effective math teaching practices, has this to say about establishing mathematics goals. Effective teaching of mathematics establishes clear goals for the mathematics students are learning, situates the goals within learning progressions, and uses the goals to guide instructional decisions. Notice here there are 3 components. First, goals should clearly identify the math students are learning. Goals should be clear about the type of learning and the depth of that learning. Second, goals should be situated within learning progressions. That means goals should work together, like stepping stones, to build our students' understanding toward all of the learning identified in the standard. And goals should also be used to guide instructional decisions. Everything we say and everything we do should be gauged against the goal. So let's break this down into something we can work with. Learning goals are the most effective at clearly defining what our students should know, the conceptual side, and be able to do, the procedural and application side. That is, our goals should clearly state the mathematical ideas, the concepts, the connections, and the relationships that we want our students to understand. And goals should also identify any procedural understandings we want our students to know. But keep in mind, if our goal is for students to gain a conceptual understanding, then that goal should not restrict students to a single procedure. We also need to make sure that our goal supports the learning in the standard. So our goals need to be standards-based. That is, we write our goals to address and support the learning identified by the standard. And going along with that is understanding where the learning of this lesson fits in the learning progression. Also important is when we're writing learning goals, we want to use action verbs. Things like students will describe, students will illustrate, students will generalize, students will compose. So here's a list of action verbs that's helpful when you're writing your learning goals. I've also included a PDF copy of this that's available on the slide after this video. Also important is how will students demonstrate the learning that's identified in the goal. The action verbs that you use to write the goal determine how students will demonstrate that learning. So when writing learning goals, keep the following questions in mind. What should students know and be able to do? How does this fit in the learning progression? What aspects of the standard is this developing? And how will students demonstrate the learning? The goals we sometimes see in our textbooks are performance goals. And although procedural practice is important, the book may not always address the conceptual aspects of the standards. So it's important for us to take a look at how to rewrite a performance goal as a learning goal. So in this example, the performance goal states that students will be able to find the area of a triangle using the area formula A equals 1/2 base times height. Now this goal aligns to the 6th grade standard 6G11. This standard says that students will find the area of right triangles, other triangles, special quadrilaterals, and polygons by composing into rectangles or decomposing into triangles and other shapes. And they're to apply these techniques to the context of solving real-world and mathematical problems. The purpose of this standard is to develop our students' understanding of the relationships of the area between different polygons and connect that relationship to derive and use their area formulas. So this standard is basically the justification of our area formulas for polygons. Does the performance goal here support the depth of learning this identified in the standard? Not really. So let's talk about rewriting this performance goal as a learning goal that addresses the rigor of the standard. So here's what the learning goal might be for a lesson for area of a triangle based on this standard. First, a learning goal for this lesson might be for students to understand the area of a triangle is 1/2 of its length times width. Second goal, the relationship between area and length and width can be generalized as a formula. And the third goal for the lesson is that students will understand there are several equivalent ways of writing the formula for area of a triangle, and each can be related to a physical model. The learning goals for this lesson support students gaining that conceptual understanding of the area of a triangle and how it's derived by composing into rectangles or decomposing rectangles into triangles. Students should be able to see that connection between the area of rectangles and triangles in order to derive that formula. And this gives them an opportunity to explore equivalent formulas and relate them to physical models. This goal addresses the conceptual, the procedural, and the application aspects of this standard. So how would a student be assessed under this standard? Well, students would have to demonstrate how to compose or decompose between rectangles and triangles to find area, and then maybe explain how they derive the formula of a triangle from the area of a rectangle, and explain how the equivalent ways to write the formulas are connected. So that's just some of the ways students could demonstrate their understanding of the learning goals. So now you try. I'm going to give you a performance goal, the standard it's related to, and I want you to try to write it as a learning goal.